So we'll talk about now PIM dense mode, different variant I was studying you yesterday. We'll make one diagram, topology. On that topology, I'm going to explain multicast server, router, one more router. This is your R2. This is your R2. This will be our R1, R3, R4, R5. Okay. This flooding is like, if you will recall your course here, like LSA flooding happen, same kind of a concept. Okay, now your this is dense mode, PIM dense mode we're talking about. And this interface is S0/0. This interface is S1/0. This interface is S1/1. This interface is S1/0. And this interface is S1/0. Okay. Now, first of all, they should become PIM neighbor. Here also, they will become PIM neighbor. Okay. And then what will happen? From here, a multicast stream will come. S comma G in your dense. Source is suppose the multicast server IP, and destination is 239.1.1.1 is on multicast. Okay. Now we'll talk about, like, maybe on this side someone is listening or not. I'll give you different examples. So what will happen? First of all, we'll talk about when packet is hit to this router. When packet hit to this router, okay, first thing we discussed yesterday also, RPF is performed, reverse path forwarding. And according to when it is success, it will do an M route. It will create an M route for 3 minutes of idle timer. Okay, and S comma G, it will put like that. Incoming flood is coming on F0/0. Okay, and then flood is going towards two sides. One is when flood will hit here. Now try to understand what will happen. Now just recall your IGMP. Here IGMP is enabled. When you enable PIM, IGMP will be automatically enabled. That practically I will send you today one video also to go through that. Okay. So this is the IGMP is enabled here. Recall your IGMP to host concept. Right now there is no guy. I'll just make a note. What will happen? You have I have told you each and everything. No one is listening to 239.1.1.1. Okay, so what will happen? IGMP will going to send something called group specific query. Group specific query. So what will happen? This guy will send a prune message that no one is listening. Here also one flood will go out. Now try to understand when a flood is a success, meaning if someone is listening. I'll just make a note here again. Whosoever listening to that group. See, if someone is listening to a group, suppose someone is listening to 239.1.1.1, never reply won't come. If no reply is coming, meaning they have accepted the flood. If they have not accepted, prune will come. So it will never reply anything because implicit join. Because they have done implicit join. Now you will notice here outgoing interface in the table, outgoing interface, we have S1/0 and S1/1. Here it will be written prune dense for 3 minutes. Now it is prune for 3 minutes. Individual timer. This is MRoute timer. This is interface individual timer. And then this is S1/1. Sorry, S1/0 is not prune. So yeah, it is 1. S10 is prune, right? S1/1 it is written like this. Forwarding. You can forward the flood here. Dense. First of all, this concept should be there in your mind. And I'll just make a note for this guy. This R2. The R2 once prune, you will send a new flood. Now flood will be stopped for 3 minutes. You will send after 3 minutes now. What you can send? Flood. Now no flood will be go in this direction for 3 minutes. That is the rule. Okay. So to forward flood packet, you should be a PIM neighbor. First of all, that what is my point is this. To forward flood packet, you should be a PIM neighbor. You should be a PIM neighbor. This is like first variant so that you understand. See, these points you have to understand. I'll just repeat again. First of all, if you are not listening, it will send IGMP will send group specific query. No one is replying prune message. Here it will be written prune, but flood won't go for 3 minutes. Here flood will go continuously and no reply will come. Whosoever listening to that group never reply anything because of implicit join. Okay, to forward the flood packet, you should be a pin neighbor and R2 once prune, you will same point. 3 minutes, your bar. Okay, this is how yesterday we discussed. First RPF is made, then M route will be done and all this. Now, one more thing I'll explain you. I'm just clearing this all. The topology will remain same. I'll talk about the right hand side. Conditions are there. Now, next concept is called prune override concept. Let me clear everything. You won't get confused. Okay. Now try to understand. There could be a situation. Situation is concept is called prune override. Prune override. Okay. Or we can say join message. Now problem is I'll just let you know. R3, I'll just make a note for you guys. Now where should I do? There R3 is connected to switch and R4 and R5 is also connected to R connected. Okay. Now R5 is also connected. So they are like a complete single LAN. Okay. Now when flood will go here, one flood will go here also. From here flood is coming. Other side flood will go here also. Okay. Now there could be a possibility. This side no one is listening to 39.1.1.1. This side someone is listening to 39.1.1.1. Okay. So what will happen? Second point I will put. You R4 side. No one is listening to 39.1.1.1. So what I will write, R4 will send prune message. This guy will say that okay, no one here, they will going to send a group specific query. Okay, and he is sending here a prune message. Because this side no one is listening. Now try to understand. He will send a prune. Once R3 and R5 will get a prune. We try to understand if, see, in this side is accepting flood. He's not sending any prune. He's accepting the flood. Okay. Problem is when he will send a prune, this guy has to send prune here also. So it will be blocked. Got it? The problem is if this guy is saying prune, this prune is again a multicast, right? So this prune message will go here, one prune will go here. If R3 will get a prune, he will send a prune here and this link will be blocked. But problem is this guy is listening. Okay. So what happens when R4, that's what I'm writing, R4 will send a prune, and once R3 and R5 will get a prune from R4, get a prune from R4. On R3, what will happen? Always remember, here we have something called 3-second delay. Immediately always remember, any router won't send a prune. Okay, it wait for 300 seconds when it receive a prune. When you receive a prune, every router will wait for 3-second delay. Now it just because situation could be like this. See, this guy prune is received, he is not immediately sending prune here, he is waiting for 300 seconds, and when this guy will see a prune message, he will say, how come someone is sending a prune message when I am accepting? So if he won't reply anything, it is like suppose I am saying anyone is here, this he is saying no, whoever you are looking for, I am not here. If you are that guy whom they are looking for, you have to reply him, because now he will go out, because this guy has replied him, that guy is not here. So what you will do, you will reply I am here. So for its presence, that still on this side I am listening to that particular multicast address, what this guy will send, this guy will send immediately a message to R3, which will go to R4 also, that is called join or prune override. Do not send a prune override concept. So R4 will send a prune and R3, R5 will get a prune from R4. Okay. So what on R3 we have, as I've written, 3-second delay. Okay. And here I'll write the fourth point. And R5 is listening to that group. Then what R5 will do, then R5 immediately send prune override towards R3, so that R3 does not send a prune to R1. Prune to R1. Okay. So this is your prune override concept. It is important. So, third concept. Sorry, it was disconnected. Third concept. Okay. Now you need to understand one more thing. As I have told you on this side, this concept is called graph message. Draft concept. What is this concept is all about? When I told you you were sending a flood here, and this guy has sent a group specific query. Okay, and no one replies, so he sent a prune. So when a prune is went out here, I've told you no flood will go for 3 minutes. Now what if within like a next second or after 5 seconds, someone has joined here 239.1.1.1. But the problem is this link is blocked for 3 minutes. So in that case, what they come up with the concept, they come up with the concept of graft. Graft will going to overrule this concept because this is blocked for 3 minutes. Whenever someone will join, he will immediately send a graft. Immediate. A graft message will come and graft acknowledgement. The graft message is telling you that I am overruling your 3 minute concept. Okay, because I cannot wait for 3 minutes. Otherwise, there will be a big delay because within a second someone has joined and it is proven already, but I have to join it. So for to overrule that, graft and graft acknowledgement they make. So I'll just make a note for you guys. R2 send prune. Now R1 is saying R1 now after 3 minutes again flood will generate it after 3 minutes. Again flood will be generated. Okay. Now I have told you what if anyone will going to join within that 3 minutes, someone will join a multicast group. So there he has to wait for 3 minutes. So latency is there. Instead of that, they come up with a concept called graft message. As I have told you what graft message will do, it will immediately it is going to send graph message immediately which violates (3 minutes) rule. Okay, and graft act will come and graft acknowledgement will come, then it will start flood multicast packet. Multicast packet. Okay, this is your advantage of graft message. Now, different scenario, graph will going to take a time. See, suppose they will make a diagram like this. Here in this like in this topology, we have some like disadvantage. See, one is you send a prune, and then immediately you are sending a graft. So when you will send a graft to the next router, he will send you graft tag. When you will send graft to this, graph acknowledgement. When you will send graft to this, graft acknowledgement. So in the linear, like this daisy chain method topology, this is how it works actually. This is I made two router only so that you won't get the concept right. So actual concept is when graph will go here, graph tag, graph tag, graph like this. So in this way, little bit latency will be there. But then it's a good concept. It is overruling that 3-minute concept. Okay. And the last variant is in your dense mode. Assert message. Now, see this. This is your R3. This is your R6. This is your R7. This is your R8. Okay. So few users are here who are listening to 239.1.1.1. It seemed like the in IGMP we studied that two guys could not be a query. So as explained, a flood will go here. A flood will go here. See, only one guy can send in flood to this particular guy because here two guys can send a flood. As explained before also in the previous IGMP, this flood will go here and one copy will go here also. Likewise, this from here a flood will go here and one copy will go here also. So when, see, because of your RPF fail, RPF check, it will be failed. So loop is prevented, as I have explained you before also. Okay, but now try to understand, I'll just make a note. Now once RPF fail to avoid loop, okay, when receive a packet from each other, assert come in a picture. Assert will go and decide who will be active and who will be standby. Who will be active and who will be standby. Okay, that will be for every 3 minutes. Assert will be there. Lot of CPU it will eat up. Okay, so actually, what is the criteria of assert messages? First, it will check the AD. If it is lowest administrative distance, that guy will become. If suppose both are using OSPF, then no issues. Tiebreaker is metric. Now metric lowest, now they calculate the lowest metric. See, suppose I have run OSPF over that. The lowest metric. If metric is also same, tiebreaker, IP address. Now source IP of this. Okay, we will check highest IP. Always remember highest IP. Okay, whosoever will going to win, that guy will become a winner in the last. Okay, this is how it's easy. Dense mode. This is how they select the particular who will send a message. Sorry, flood. So today I'll send you one video, but before that, on all the routers, when you do configuration, okay, you have to enable first of all IP multicast routing should be enabled. Okay, and then interface loopback 0. Under the interface, wherever you want to suppose initiate that you want to implement that on this interface, multicasting should be enabled. So you have to type IP PIM dense mode. All the interfaces wherever you want. Okay, and suppose a router which I am making as a client. I've told you IGMP is enabled. So here in the topology, one router will acting like a router is acting like a client. So he's listening to that particular address. So what you have to do is go to his interface F0/0 and type a command called IP. When I'm saying that they are listening to some particular group, IP IGMP join group support to 39.1.1.1. This is for client. See, when my diagram is like this, when I was explaining. Okay, here you have to type all these commands. Here you have to type these commands. And when you enable PIM, IGMP is also enabled. Okay, to check the neighborship, show IP. First of all, PIM interface will tell you that what all interfaces are PIM interfaces. Show IP PIM neighbor will tell you who are PIM neighbor. And then show IP mroute will tell you the multicast routing table. Show IP mroute. Okay, so today I'll send you one video for this practical of PIM dense mode. Just go through. Then we can start PIM sparse mode also. A lot of things are there. Okay. So today I'll send you definitely.